So my name's Amy Woods. I'm a technical product manager with Titan Environmental. I head up the Stormwater Management Group. We recently worked on a project in BC. It was a residential project that had some challenges. We had a certain amount of storage that we needed to fit within a small footprint, but we had some grading issues that we needed to address. So when we looked at what our competitor had provided, we had some concerns with the installation. We were provided a drawing set by a contractor to review. They were initially looking for just pricing on the system, but once we started reviewing the drawings, we had a lot of concerns. So we ended up reaching out to the consultant to address those concerns. It was going underneath a parking lot, but above a parking garage, and the driveway sloped slightly, so there wasn't as much cover from one end to the other end. The main consideration was the storage volume, but there were some elevation controls as well. We couldn't move the tank down, and there was very limited cover above the tank. The design challenges that we faced were two. So the first one was that they had two different tank heights side by side, and obviously one was higher than the other one, and there wasn't anything separating the two. And then the second concern that we had was there was a stone leveling bed above the concrete slab. So the reason that this is a concern is twofold. So when we have two different tank heights, the taller tank doesn't have any support on the side of it. There's no lateral support. We need to separate these and have some kind of structural fill in the middle. If we don't, that taller tank is subject to failure. You can have earth pressures that are going to push on it, and the columns are going to start to buckle. And then probably within, I would say, the first year, it would have been a complete tank failure. So there is just not enough support on the side of it to be strong enough. The second concern that we had was with relation to the stone bed. So almost all of these underground stormwater systems have a stone bed at the bottom, and that's mainly for leveling. So we just want to have a nice flat surface. With this project, they had the leveling stone bed above a concrete slab. And if you picture a concrete slab, it's very level, it's very firm, and it is the most ideal thing to build on. There was absolutely no reason to add a leveling bed above that. Not only did that take room that we had in the available height, because now we have 4 or 6 inches of stone below the tank, but it's also harder to build on. Now, like I said, most of the times we're building on a stone bed, and that's just the way it is. We compact it, but as we're walking on it, as we're placing tanks, it does get a little bit uneven. So if we have the opportunity to build on a level concrete slab, that's absolutely the way to go. We were able to come up with some design revisions based off of all of our knowledge and experience. We have a full R&D group. We have a team of engineers. We've worked on tons and tons of projects over the years. We've seen so many different design challenges, and we've been able to go to look at different geosynthetics uses and designs to implement them into these other projects. And just over the years, we've been able to vet out lots of different solutions. We collaborated extensively with the engineering team. Once we pointed out some of the concerns that we had a lot of questions coming back to us. Obviously, they were concerned that not only were they going to now modify their design, but they need to be very, very confident that we knew what we were talking about. So there was a lot of conversations, a lot of meetings, a lot of phone calls, but then we also had to provide a significant amount of backup information just to support our statements and our claims. Once the design was finalized, we just partnered with our distributor and the contractor to make sure they had all the information that they needed, the full installation guide, and we were on site to support them during the installation to make sure everything went smoothly. So eliminating that stone bed was going to make things a lot easier, and we just needed to make sure that we actually moved part of the system. We expanded into another area where there was more cover available, and we were able to reduce the footprint slightly just because we could increase that tank height. By changing the design, really the one main item was saving in the placement of the stone. So we saved on the stone itself, and then we saved on the placement of the stone. And then the installation went probably 20% faster because we didn't have that stone in the way. If that system had gone in as originally designed, I do not believe that it would still be functioning today. I believe that there would have been a failure due to the lateral support. So the fact that they were able to go in and place a system that will be there for, a 50-year design life, that is the success. The lessons that should be taken from this, I believe, are just making sure that people are partnering with someone that really has the experience and the knowledge. These are critical systems. They're buried underground structures. There are a lot of different implications to them, and we need to make sure that they're sound. We need to make sure that they've been designed with all of the possible parameters that we could be looking at, whether these systems are in parking lots with piles of snow on top of them, or if there's overloaded cement trucks that will be running over them at some point in time, if there's high groundwater. There's lots of different things that we need to look at, and it's really important that you have somebody that is looking at all of these things and has the understanding of how it all works together.